All right, so moving along, we just talked about the fact that gases are easy to compress. I do want to mention again from last unit the pressure. Standard pressure in conversions, 1 atmosphere is equal to 760 millimeters of mercury, which is also equal to 101.325 kilopascals. Those three different units of pressure, atmospheres, millimeters of mercury, and then the kilopascals, and being able to convert. If I were to, whoops. Let me see if I can get rid of that temperature. Convert between those. Again, if I have, I'll move up here. If I have 740 millimeters of mercury, I can easily convert to atmospheres. X line, you know I like that. mmHg, ATMs, 1, 760. And you would divide 740 by 760. I don't know exactly what it is off the top of my head. Let's say it's 0.98 atmospheres. If I wanted to do the same thing, 740 mmHg, and I wanted it in kPa, kilopascals, X line, mmHg is what we're given, kPa is what we're solving for, it's just a unit conversion, 101.325. 760, I would multiply by 101.325 on my calculator if I was doing it, hit equals and then divide by 760. Again, I'm not sure exactly what that is. Let's say it's 99.8 kPa. We know it's definitely going to be less than 101.325, just as it's going to be less than 1 atmosphere because we have less than 760 millimeters of mercury. Okay, so those are things to remember from last unit. Additionally, since temperature and pressure is easily affected or easily affects gases, I do want to mention temperature, and we should be aware that we should be able to convert between Celsius and Kelvin very easily. This is something that's going to be very, very important as we go through some of our gas laws, because temperature is going to need to be in Kelvin all the time. So if you're given a temperature in Celsius, you would need to add 273 to that. Okay? 30-degree temperature in Celsius is 303 Kelvin. Okay, so that's again something pretty simple. I do want to very quickly, and I'll use this on the same video, some measuring units, I guess I could say, and factors that affect gases. Here are some very quick ones: the amount of a gas, the volume, the temperature, the pressure. And I want to very quickly just remind you. Okay, these are the variables. These red things circled are the variables that you're going to be using for formulas, okay, and the factors that affect gas. Volume can affect a gas, temperature, pressure, etc. Okay, I do want to now also just say our units. Okay, so those are our variables. Our units are labels. Obviously, the amount of a gas is in N, the variable for moles, so that's going to be moles. And again, these are our units / labels. Okay, moles. Volume, we're going to use in liters. Okay, liters. Temperature is going to be in Kelvin. Remember, if you have degrees Celsius, you must convert to Kelvin. And I'm going to remind you, it's not a must, but for the formulas that we have, for the constants that we're going to use for the ideal gas laws, we get to it, you'll see that it needs to be in Kelvin. Okay, and pressure, I'm going to put ATMs, and that's primarily what we're going to be using, but I do want to say or mmHg, millimeters of mercury, or kPa. And again, you'll see there are different units that can be used, but primarily we're going to be using our unit for pressure in atmospheres. So again, if you'd be given it in millimeters of mercury, kPa, you would convert to atmospheres. But we will see millimeters of mercury for things in this unit, such as barometer or manometer measurements. Okay, so there's some measuring and some factors that affect gases. And again, really what we're doing is just kind of setting the tone for this unit.